Hi guys, welcome back to the channel. In today's video, we'll fix some common issues with the PlayStation 4, specifically the blue light of death BLOD and the problem of the console abruptly shutting down. We will guide you through the process of diagnosing and troubleshooting using an SMD tester. First, let's look at its malfunction and what it does. At times it turns off after a while, but other times it turns off right away. This means there are likely two types of faults, one related to the secondary power supply and the other relates to booting issues. The blue light is staying on again now. We're tackling a common but frustrating issue with the PlayStation 4 sudden shutdowns during gameplay. This problem can be quite a headache. Now it has powered off again. Now when I try to power it on, it just powers off again. So if you're ready to get your PS4 back in action, let's get started. Originally, the PlayStation was returned to its owner by a repairman who apologized for fixing it, and now it's here to be repaired. You can see that there are different screws installed instead of the company's screws. I don't understand why these mechanics have this bad habit. Before we start diagnosing these issues, make sure you have the following tools ready: SMD Tester, Multimeter, screwdrivers, thermal paste, flux paste, isopropyl alcohol, and a clean anti-static workspace. Let's start with the blue light of death, often known as the BLOD. When your PS4 shows a continuous blue light, it means there's a hardware issue preventing the console from booting up properly. This could be due to various factors such as a faulty component, a bad power supply rail, issues with the APU accelerated processing unit, the internal RAM module, or their biases. Sometimes a damaged or loose connection under the APU chip can cause this problem. This error can also occur if the RAM cannot communicate with the processor for some reason. We need to check the motherboard while keeping all these things in mind. As you see in other YouTube videos, no one considers these things and moves on to something else. If you ignore all these things and start heating the APU, things will worsen. The next issue we need to address is the sudden shutdown of the PS4 after some time. This could be caused by overheating, power supply issues, or problems with the internal components, such as the FET power not being able to handle the load of the APU chip. In most cases, this issue occurs when the power rail of any component is not functioning properly. Let's remove the motherboard for testing to diagnose the problematic components. Finally, we got the motherboard out. When it comes to diagnosing small surface mount devices SMD such as resistors, I depend on the accuracy of this SMD tester. To begin with, if we check for BLOD issues, we will inspect around the processor. If we are checking for abrupt shutdowns, we will inspect the power rails. It is the three resistors that are mounted in the corner of the processor that often cause this BLOD, which shows a value of around 198 ohms. I think the first thing we need to do is diagnose why it shuts down so we can find the next fault. This section of RAM, the CPU section, and the mounted RAMs on the back side are related to the BLOD error. Let's move on to the sudden shutdown error. These error amplifiers compare the reference voltage of 0.65 volts with the output voltage to drive the output N-channel FET. It has some bias resistance and feedback resistance. It is very important to verify the value of the feedback resistance, and it is around 500 ohms. Similarly, other error amplifier comparators may have different feedback resistance values, but it is important to verify these as well. The error amplifier compares the reference voltage VREF output by the reference feedback voltage VFB divided by the feedback resistor to control the output driver on resistance to ensure the output voltage Vout is maintained at the required voltage. Amp input voltage ranges from ground to 2.7 volts, while the amp output ranges from ground to VCC. When enable is off or UV low is active, the output goes low and the output of the N-channel FET switches off. To prevent malfunctions during a momentary decrease in VCC, the UV low circuit switches the output off. Since different models use different biases, if I can't remember a bias value, I compare it with another board of the same board number. The V in-line acts as the major current supply line and is connected to the output N-channel FET drain. When the output voltage Vout drops, the IC assumes that the Vout pin is shorted to ground and switches the output voltage off. The little ones have an important role to play, and it's challenging to cover all their details in one video. Therefore, I'll have to create a separate video for each. No defective components have been found here yet. We will not leave until we find the fault in it. Now let's proceed to the next section regarding the same error. Before we proceed, let me explain the functions of these two regulators. They provide the required 5 volts to the HDMI port for detecting a display TV as a peripheral device in the console. Next, we need to verify the secondary power rails for the GPU section of this APU chip. The PWM chip drives the N-channel FETs, which then charge the inductor coils to produce the required voltages. All the biases and coupling resistances play a crucial role in maintaining power for the GPU section. The input coupling of the rightmost N-channel FET is at 1 ohm, providing a 5 volt input. The input coupling of the other N-channel FET is at 10 ohms. Each FET is biased using 10 kilo ohm resistors to provide 5 volts positive and ground biasing. Let us verify each one of them. Why are their values not giving the correct estimate? There seems to be a significant change in them, which is showing their value in mega ohms, while they should not show more than 10 kilo ohms. Yes, it seems to be faulty due to a significant change in value, while the other resistors have a resistance of 10 kilo ohms. Another bad resistance has been found which is just as bad as the other one. Wow. Another resistor with a value of around 30 kilo ohms is found instead of 10 kilo ohms. If you check the resistance values on another board, you can verify them. This is 10 kilo ohm. The second is also 10 kilo ohm. The third is also 10 kilo ohm. The fourth is 10 kilo ohm. The fifth is 10 kilo ohms, and the final is also 10 kilo ohms. While in this board, some of the values are staggered. So we need to change 3 of these resistors. Let's first reflow them and check if there's any significant change in the values and if they get fixed. It still seems to be bad. Two of them have reverted to their initial values. This has to be changed. This one is an undeniable type of resistance. Okay, fine. It looks like it has the right value, so let's change it. Ensure that both terminals of the resistor are well connected to the motherboard solder pads. I'll make sure to double check all of their values right away. All are now set to their original values. Now it's time to review the progress. I believe it has resolved a problem that previously used to shut down. It seems that the second issue, the blue screen of death, is still unresolved. Still, the blue light is not turning into white. The device is not turning off, there is no press button beep sound, and it seems frozen. Don't give up. As previously discussed, the blue light issue arises from problems with the processor and RAMs. And you can see that there are 8 RAM modules installed on the back side of this motherboard. And on the front side of this motherboard, there are bias resistors for all the RAM modules around the processor. These biases are in the form of 4 different pairs of values. And there are 8 resistors with a value of 120 ohms on the back side of the motherboard. All 4 resistances and all 4 pairs must be checked very attentively. First, check the bias resistors located at the corners of the processor. One of the resistors in this pair should have a value of 120 ohms. Fine. One of the resistors in the other corner pair should also have a value of 120 ohms. The second resistor in the pair should have a value of 1 kilo ohm. These are fine. Let us examine the remaining pairs as well. They have 2 sets of 4 resistors, each with a resistance ranging from 1.5 kilo ohms to 1.6 kilo ohms. These are definitely not their actual values, they just show that the value of the next resistor pair is 60 ohms. That is the actual resistance value of these resistors. Actually, it indicates that the machine is not booting up. A computer comprises 3 main components: the processor, RAM, and programs. If any of these things cause a problem with data processing, the system will not run or boot up. Please be mindful of the following sequence as it allows us to systematically check all resistance pairs. The resistance pair at the third corner of the APU is also to be checked. Still, nothing has been found bad. fourth APU corner pair resistor values are accurate as well. Kindly persevere and continue with your efforts. We'll keep looking until we find the cause of the issue. Don't worry, we'll get to the bottom of it. This is a PWM chip that drives the N-channel FETs to generate the secondary power supply for the GPU section of the APU chip. I will also check the coupling resistance on all the output channels to ensure the integrity of variable width pulse signals. On one side, a pair shows 2 kilo ohms and the other shows 1.5 kilo ohms. The second row of resistance involves feedback couplings. All seem to be fine. The height of the APU chip from the motherboard solder balls also appears to be correct. Don't forget to check the individual bias resistances of the remaining components. The resistance value is 120 ohms. And finally, we have found the solution to the problem. The resistance value is completely unclear, a substantial change from its original value. Let's proceed to verify the values of the other resistances of the same type. The others are okay. One of these two bias resistors is faulty. The reflow did not have any impact on it. It has to be changed. Now everything is fine. Let's check it again now. Hopefully there won't be any issues. I am going to power it on now. With God's help, you are all set to boot up and get going now. Now the key light has turned white. Thankfully, it has accepted me. Sure, here you go. Hey, let's get going. It is displayed on TV, indicating that the issue has been resolved. Wow. And that's a wrap for today's video. In this video, we delved into diagnosing and troubleshooting the PS4's blue light of death and sudden shutdown problems using an SMD tester. If you found this video helpful, don't forget to like, share, and subscribe for more tech repair tutorials. Leave a comment below if you have any questions or need further assistance. Thanks for watching and happy gaming.